Hello. All right. This video is about how Kubernetes authentication works. Okay. All right. So before, okay, yeah. So the Kubernetes cluster has API server. Okay. And on the Kubernetes server, first of all, so on the Kubernetes server, what you have is on the cluster, you have an SSL folder that has ca dot um, cert and ca dot key. Those are the Kubernetes is a self-certified CA. Okay, it has. Okay, and then the API server also has its own certificate that is signed by the CA. Okay, so the API server pretty much it has a certificate that basically says that it is who it is. So it has got a you know common name that points to the host name of your Kubernetes cluster. Okay. Now, when there are multiple ways to authenticate with Kubernetes, okay, one of them is to use certificates. Okay. Second is to use token, but first we will talk about certificates, right? So when your Kubernetes client, it could be kubectl, that tries to connect to the API server because all communication happens with the API server. Okay, when it tries to communicate with the API server, you it contacts via HTTPS to the API server on the default port of 6443. When it communicates with the API server, okay, um, the API server sends back its certificate. Okay, its certificate. Now, when the certificate comes back to the client has to read the certificate. How does it read it? It should already have the Kubernetes clusters. Um, what is it called? CA, right? It should already have the Kubernetes clusters. The CA cert. Okay. If it has the CA cert, then it will open the certificate that API server sent. That opening verifies that the server is who it is because there is a common name that points to the host name, right, or the IP address. Once that is verified, then the client using the CAcert will create a shared key, okay, encrypt it with that public cert, public CA, and send it back to the API server, and the API server will open it with its the CA private key, and if it's able to open, that's where the SSL handshake has completed. Okay, now let's walk through this process, right? um, so for all this to happen, right, the authentication is done by modules within the Kubernetes. So you can have any module and any method of authentication. This is one method of SSL authentication. For this to happen, you need to um, pretty much this is by default. You need to specify that the client CAcert is this guy. Okay, uh, client CAcert equal to ca.crt. Okay, now when okay, okay, great. Now I said your client kubectl in this example needs to have the CAcert. How do you have that? You can have it in the kubeconfig file. In the kubeconfig file, There is a key for cluster where there is a key for certificate authority data. This is your Kubernetes CA cert. Okay, it is actually in base 64. Okay, so when you open it up, it will be this certificate. Pretty much, this is what is your CA cert. This is embedded when you generate your kube config file. It automatically gets generated, but the main piece is, this is the CA cert that is used to decrypt encrypt on your client. Okay, so that's the part where the SSL thing communication happens. If you read this here, so is a cluster has a CA cert, reaches over HTTPS, sends it cert. Okay, creates a new shared key, and the connection established. Okay, now second piece is, now that the handshake has happened, how does authentication using SSL certs work? It's pretty straightforward. What you need to do is you need to sign a client certificate using the CA cert of the cluster, and then present it to Kubernetes. That's it, and that's how, once you have the client cert, then you are able to communicate. Let's see how it works. Okay, first what you need to do is generate your own key, then generate a CSR. Okay, um, once you generate a CSR, okay, um, when you create the CSR, you would specify a common name that is going to be your user ID. Okay, and you would also specify OU, which would be the group, which is where your authorization comes in. It has to be the name of your RBAC role binding. So whatever rollback uh, that you provide here is you would provide it in the group, and that's what this particular user will have. So once you set the common name and OU, right, you generate the CSR. When the CSR is created, you'll create a YAML file. This is a typical Kubernetes YAML file, with in this format. Then you submit this to Kubernetes cluster, and that's it. Once that is created, it gets approved, and once it's approved, you are good to go. So now anytime you log in, you communicate with kubectl, you're authenticated using this certificate. Okay, now let's look at second more popular way. Okay, the first was to use um, certificate. Second is to use webhook. Okay, so how webhook works is you configure your kube API, your API server with a authentication method called webhook. So what you do is, when you set up your kube's API server, you specify webhook as one of the modes, and then you provide a YAML file. Webhook is nothing but anytime a request comes to the API server, it's supposed to call another another HTTP server. Okay, and then that HTTP server responds back. So this is called callback. This is called callback. This is how webhook works. And wherever its API server is calling, the response it gets is what is used as part of the authentication. Okay, all right. So how this is actually used is, this is kind of used in EKS. Okay, now let's go to EKS. Right, how is this implemented in EKS? That's how webhook works. But in EKS, what you have is a IAM. Basically, in EKS, all the users exist in IAM. Okay, So the big picture is using your IAM user ID credentials, access key and secret. Okay, you communicate with your EKS cluster. What the EKS cluster will do is it will make sure check that that particular IAM user exists or the role exists, and if the role exists, then it's going to come back and check a config. It's going to check a config in your Kubernetes cluster to see if it has the necessary roles. If that IAM user or role has the necessary roles, then you are allowed to access. Okay, that's so let's see how it works. So you have a AWS IAM authenticator as a pod running in the control plane. Okay, um, from your client side, what you would do is you would first run this command, AWS EKS get token, and before you run this command, you would have your secret and access key set up in your AWS config file. Those are the credentials it will use to run this command. To run this specific command, it's going to use those credentials. Okay, so see here, set up this guy, and when you do this, and you provide the cluster name, what it would do is it will generate a token. Okay, it will generate a token. What is this token? This is nothing but this token allows uh, your pod, the admission controller pod, to actually make the same call that you did, and it will do this basically. It has all the, it is like a signed HTTPS request. And when now that you have executed, right, this token has everything that is needed to run this command. But this command is going to be run by the pod. Which pod? This pod, right? The authenticator pod. It'll run on your behalf, but because it's got all the credentials, so when it runs it, if it gets this response, it knows that okay, this your the IAM user or role already exists. So that's all it needs to do. It is checking whether the user exists in IAM or not. Okay. All right. So once it knows it's there, um, we'll move to the next step. Now, instead of running this, you could also embed this within the kubeconfig file. Kubeconfig file, pretty much what you do, uh, the same config file, you have the certificate authority, blah, blah, blah. And you actually embed the command for the EKS get token here. And anytime this runs, okay, again, you got to have your credentials sitting, okay, on your server, on your client, access key and secret. And anytime you run this, this is embedded, it will run and it will generate a token. Okay, and the token is used by the authenticator to make sure, check whether that I user exists or not, right? Okay, so that's it. So this is how you do that. And next what happens is auth z, right? For auth z, there is simple, there is a AWS auth config map. Okay, within that, the same user that you just checked must exist as part of, okay, map users. Here the user should exist, and whatever permissions you provide here, the same IAM user would have the permissions. Okay, so that's how it works. Once you have these two things, once you have this setup, uh, your your client can communicate and connect. All right, that's all I have.